Just like what I mentioned earlier, that one of the questions are looking for the weight, which is mg. So I'm gonna go ahead and start working on the next problem that I want you to go ahead and do it. Follow along with what I have. So let's look at the picture. So by just looking at that picture, we are able to assume that the angle between the wire would be 80. At this point, do you see where I'm going? So the total angle between the wires should be 80 because when we split it in half, it's 40. So this one, you're just gonna go ahead and have to like double the angle, which is 80. And one other question suggests that the maximum tension in each wire is about 750 newtons. So, and the angle in between is 80, just like what we were saying, where the horizontal component is 482 newtons. So with that being the case, so you see that I put in the T side data, just like what we've been doing, that the force in that direction is always a T, which is the force of tension multiplied by sine 40 is equal to 482 newtons. So therefore, when we are tasked to solve for force of tension, then you're just gonna go ahead and rearrange it in such a way that 480 divided by sine 40, and that will give you the answer of this one. We're gonna prove that in just a minute. So let's start by doing this question together right now. So first thing you do, you also draw a free body diagram, which is represents the forces, and then you can go ahead and draw the arrow 40. Go ahead, T cosine 40, T sine 40. Let's look at what else they have you. At this point, they also tell you that the force of tension is the same. So therefore, I'm going to have to draw another forces, which is T cosine 40. So basically, I have two T cosine 40 pointing upwards. So what this means right here is that at rest, these two forces combined must be equal to the weight. And we're going to go from there. So sigma y equal to 0 because it is a static equilibrium. If the forces act pointing upwards, since we have two, I'm just going to go ahead and combine them. When I combine them, it's actually 2t minus mg equal to 0. Does anyone know how I got 2t cosine 40 from the picture? You may want to talk to me right now and discuss this class for extra credit. Then you trying to isolate the 2t cosine by itself. So with that being the case, I'm going to have to add the weight on both sides of the equations. So when we go from this step to this step right here, I only have the weight on the right hand side, which is what we're looking for anyways. So I'm just going to go ahead and write down weight. That's what you're looking for. So now you may want to go ahead and substitute your values. 750 cosine 40. So basically you would do just multiplication just like what you see on this board right here on the calculator. So you would just go ahead and press 2 times 750, 2 times 750 times cosine 40, press enter. And the answer will be 49 newtons, that is equal to mg. So at equilibrium position, you know that the force up must be equal to the force down, and the force to the left must be equal to force pointing to the right.